Hello everyone and welcome to today's class. We will be talking about bar chart schedules today. So in previous classes, we covered the fundamentals of the construction industry. I tried to provide a general image or a big picture of how this industry functions and where planning and scheduling stands in this industry. So I tried about the RS means data book in the lab, and now, previous class we talked about the activities, how to identify the activities, what type of work could be called a construction activity, and today we will be talking about the first type of schedule, which is the most common one, and that is called bar chart schedules. So, like I said, bar chart schedules are the most commonly used method for planning. There are a lot of advantages with them, but the most important advantage is their simplicity. They are easy to understand and follow almost by anyone on the job because every day is given a column. So days are shown on the x-axis and the activities are shown on the y-axis, okay, starting with the first activity on top, and then other activities will proceed to bottom. So the order we set them is from top to bottom, and time-wise they're from left to right, okay. So we assign one cell for every day that an activity takes. For example, here we want to say that planning takes 3 units. That could be weeks in this case, but in our schedules, time units are almost always days. Okay, so what else do we know about them? They have two names. The other name of bar charts are Gantt charts, and that's what because the person who first developed them was called Henry Gantt. So if you hear Gantt chart, it's nothing new. It's the same thing as a bar chart. So the good thing is that they provide a graphic representation of the project. So I was talking about some of the advantages. I mentioned that they're easy to understand and follow by everyone. The second advantage you could think of is they show what are the activities that should be done in every single day. It means that the activities that need to be done concurrently or at the same time. For example, in week 3, in this example, both planning and design will be taking place. Okay, so it's very easy to understand what activities need to be done every day. Why this is important in a construction project? In many cases, we have lack of space. Okay, especially for residential projects in big cities like downtown Manhattan, or let's say downtown Seattle. So there is a lot of work, or there is not necessarily residential, it could be a commercial project. Um, a lot of work needs to get done in a very limited space. Okay, so and each activity or many activities need their own pieces of equipment, and you cannot have a lot of equipment at the same location. So knowing what activities need to get done concurrently it can provide you with some insights that how crowded is your job site going to be. And you can actually solve this problem by looking at your schedule, and you see, for example, 5 activities have been scheduled on day 54 of the project, and they are almost close to one another, and a few of them need big equipment pieces or machines. So you just decide to change your schedule and move some of the activities to provide space. Remember, overcrowded job site is almost always a bad idea. A scheduler should do their best to reduce the overcrowdedness. Why? Because of two things. Productivity is significantly compromised when the job site is overcrowded. And number two is that in an overcrowded job site, safety is compromised because there are lots of people. So the machines the operators have to watch them, and there is a much higher chance of accidents. Okay, so the scheduler should do their best to mitigate overcrowdedness in different job site locations. Okay, so what is the process of preparing a bar chart? A project has been given to you, and I talked about fundamentals of creating a schedule in the last class. But let's say you want to schedule a project. Where to begin? The first thing you need to begin is to receive the plans and specifications. Okay, so plans and specifications, or the drawings, are the basis of creating the schedule all the time. So you use them. You use the bid item estimates as a cross check, or you use them to double check that everything that has been estimated has been considered in the schedule. So you're considering some time, you're considering an activity for everything that has to be built, or that everything that costs some money according to the bid package. And there are some other considerations that do not necessarily exist in the drawings, such as sometimes the owner has a specific expectations that they clearly state them in the contract. Okay, for example, they want specific days to have specific events to happen in specific days, or they have some milestones that have to be satisfied. So scheduler would use plans and specifications and those special requirements of the contract in their schedule, and then will double check their work by looking at the bid items. There are also some external limitations that a scheduler needs to see and consider in their schedule. For example, if the water level changes, if the weather changes, or the sunset time, that could impact how you schedule your project. And also, if you need to shut down the road to traffic, and there are specific days that you are given permission to do that, you should also encounter it in your schedule. All right, so based on that, creating a bar chart is no exception, but to make it just name the fundamental steps, you should have your activities listed. So this comes from after you know what your activities are. So now you know what your activities are. In the next step, you go and estimate their durations, so you know how long each one takes. Then you develop activity sequencing. And like I said last time, activity sequencing could be a big deal because you have to consider all the relationships and in whatever way the activities could be connected or dependent on one another. And like I said, sometimes it's not easy to understand how activities could depend on one another. Two activities that seem quite irrelevant could actually be dependent because of some reason. Sometimes it could be because of budget. For example, last month we did an activity that was very costly, and now we cannot have another very costly activity right after that, because our cash flow then it will be in a bad situation. So we probably want to put something that is less costly, so the owner will have some time to actually improve their financial status. All right, and once you have the sequencing of activities, you're good to go for constructing the bar chart. In fact, the information pieces of information that are important to make a bar chart are defined activities, defined durations, and defined sequencing. You should know the dependencies, all the dependencies between different activities before you can create a schedule. Let's dig down more into these steps. So, what is identifying activity? It's breaking down the project into discrete, work items that should get done so that the project could be called substantially complete. Okay, so usually activities are the result of breaking a small piece, one piece of work breakdown structure. If you remember from previous classes, I explained that we first break the project into work breakdown structure, which are big chunks of work, and then you break the work breakdown structure items into smaller work items, and then you can call them activities. So this is the second level of breaking a project into smaller pieces of work. Example, the construction of footing could be one item in work breakdown structure. Now, you to get that done, the first thing scheduler does would be breaking it into some activities. Those activities could be excavate footings. So we first go ahead and excavate the footings. Number two, we form and reinforce the footings. And number three, we place the footings. Okay, so we have these three steps. We broke down a work breakdown structure item into smaller pieces of work, and we call them activities. Okay, so we have these three activities. Now, estimate activity duration. If we know our activities, now we have to know how long each one take or their durations, because that is a required item for making a schedule. It could happen based on using different methods. You should estimate how long your activity will take. For example, RSMeans data book is one of them that you can make a comparison between what you're doing and one of the activities that have been identified by the RSMeans data book. And you should try the one that is the most similar to what you're doing, which is not always easy because every job or every work item is almost unique every time. But if you can find it in RSMeans data, that's great. You can use it. Some schedulers or some project managers do something very interesting, and they keep track of their, schedule information in previous projects. For example, they keep track that how long it took them to let's say, do a certain amount of excavation for a certain amount of soil. Okay, so next time they have some basis of comparison, that by comparing the quantity of this job with the job they have done before, they can find a very good or close number for the durations. They can estimate the duration with almost high precision. Okay, so it's a great idea if a company can keep track of or can record the durations in every project, so most of the time they will be able to use it in the next projects. So based on that, we continue our example. We look at historical data, or we look at how skillful are the people who are working with us in this project, and we come to the conclusion or estimate that it will take us 6 days to excavate the footing, 12 days to form and reinforce them, and 6 days to place them. Okay. So if all these activities I mean, if we could not do any of them concurrently, it means we had to finish the first one before we could start the second one, and we had to finish the second before we could start the third, then the project would take 24 days, right? Because the activities had to follow. I mean, the second and the third activity had to follow the first and second activity respectively. So, but in many cases, you don't necessarily have to wait for one activity before you can start the successor activity. In many cases, a part of activities could be done concurrently, or in some cases, not only you have to finish for one activity, but you have to finish certain days after that activity is done, and then only you can start the next activity. It means there should be a lag. For example, once you pour the concrete, you cannot immediately after that, you cannot get started with, for example, if you have poured concrete in slabs, you cannot start the next operations on the concrete because it's not ready. You need to wait 28 days, so there will be a lag. Or when you paint a wall, you cannot immediately after that you cannot start working on something else. You need to uh, provide some time, give it some time, so it will dry out. The paint will dry out. So there are different situations between different activities. But let's consider in this job, let's consider in this example that we excavate the footings on the first day. So the start activity does not depend on anything, right? That's usually an independent activity because you just decide on when to start. Okay, once you get started, all the activities will depend on that start day. The second activity, let's say it can start 2 days after the start of excavation. Why? You might say we can never we can never form and reinforce footings before you excavate the footings, right? We first need to have some space for the footings, and then only we can form and reinforce them. But you need to consider that the job site could be a big area. Okay, so let's say when you are done with the north side, you can go ahead and start with the excavating the north side. Then you can go ahead and start, reinforcing and forming in that part, while the excavation is still in place, is still continuing for the south side. Okay, so in that case, you could, identify different phases or different stages, and you don't have to wait. I mean, the team who form and reinforce footing can get started on one part on one side while the excavation is still happening on the other side. So based on a similar logic, you will start placing footings 3 days before forming and reinforcing footings finishes. That could be different based on different logics or for different reasons, but most of the time this is given to you, or if you are the scheduler, you should sometimes investigate it. Okay, you should talk with the superintendents, or you should talk with some crews and figure out. Usually, superintendent or project manager will help you out to find special logics between activities. And sometimes it's very difficult, or if not impossible, for the scheduler to figure out all these dependencies, uh, alone. So you have to reach out to people and ask them what they think about this logic, and then based on that, you might make changes to make everybody almost happy. That's the goal. Um, and almost has a meaning because you can never make them quite happy. So, is developing the activity sequencing is based on available resources, right? because in many times you have to share your resources between different activities, and you don't want to schedule two activities that need the same resources at the same time, right? Because then they have to share the resources and the productivity for both of them will be compromised. So a very important thing in sequencing activities is to understand what type of resources each activity takes and what are the available resources, and if you are able to share your resources between the two at the same time, and if not, you have to schedule them at different times. All right. Yeah, like I said, the sequencing is all about considering the relationships between different activities, how they could be connected. Now, let's dig down into relationships. How are activities related to one another? There are four types of relationships between different activities. First one is physical relationship. It means, uh, for example, you can never pour the concrete before you have put the rebars, right? First, you have to put the reinforcing bars or reinforcements, and then only it's ready to pour the concrete. So physical relationship is the strongest logic. You can never mess with it. You have to comply with it, right? It's a physical relationship. You have to, you know, schedule in a way that those requirements are met. But there are other relationships too. Sometimes you do something for the sake of safety. It means, like I said, there are multiple activities that you have to do, let's say next week, and you have an overcrowded job site, so it will probably become very risky if you want to have all your equipment at that location at the same time. So what you do is that you schedule it at different times. So because of safety relationship, you move your activities in a way that you could do your job more safely. Um, there could be resource relationships that especially applies to equipment. For example, you have limited number of trucks, dozers, bulldozers, and you need them. You need to do everything, all the job using those uh, machines. So sometimes you have to move some activities because you only have one of them, or you have to use all of them in one activity, so the other activity has to be moved. And there could be sometimes preferential relationship, which is the weakest or lowest, or let's say least necessary type of relationship. So the way it works is that the contractor will sometimes tell you, I just feel more comfortable if I do this first and then I want to do that. It just gives me, I don't know, it just improves my productivity, or I feel better, or whatever reason. They just come to you and say, could you schedule this before that? And then there could sometimes there is not a very specific reason for that, but because they prefer to do it, uh, so then you just try to change your schedule to meet what they are asking for. So which one should be satisfied first? Obviously, physical relationship. It's a very strong thing. There is no way that you can ignore a physical relationship or physical relationship requirements. So once all of them are ready to go, you go ahead and construct a bar chart. There are some questions that need to be answered before you could construct a bar chart. First one is what time units you are going to use. Are you going to use hours or days? Okay, so that is important. Should work days be used or calendar days be used? Yeah, the type of days could also be different. Are we doing a 5 week calendar, 5 day week calendar, or a 6 day week? 6-day a week calendar. So based on that, your bar chart will be different. And what about non-continuous work? Sometimes there are some pauses in one activity, and the bar chart or actually shows a continuous activity. It cannot show interruptions. So obviously for the third one, if there are interruptions, if the activity is incontinuous, then you can break it down into smaller continuous activities, because that makes following the bar chart a lot easier. Okay, so whenever you have a bar chart, it means the work is in progress without interruption. You can never say, okay, no, in this day you don't have to work, and then, if that is the case, you just cut the bar and then you start another bar for the second bar, for the next part of the job. So what time units should be used? The most common one is days. We always round up our estimated durations into days. Okay, for example, if something takes 3.7 of a day, we just say it takes 4 days to do it. That puts us on the safe side when we round up, because it creates a placeholder. If unpredictable things occur, then you have some time to to recover. So, and sometimes, however, you could use smaller time units. Sometimes you could use hours. That is the case usually for equipment rentals. Okay, and sometimes those equipment rentals are expensive, and you could go to half a day, or you could go to increments of 4 hours or something like that. That depends on how the company who rents it wants to rent them out. But it is possible that you have time units that are smaller than a day, though it is not common. So how is this determined? How is it determined if you want to use you want to have week as your time units, or month? Yeah, I didn't mention it. You could even have weeks or month as your time units. In that case, your schedule is a very general schedule. It just shows, so because every cell on the bar chart is showing 1 week, or is showing 1 month, and a lot of things are happening in 1 week or 1 month. So if you're preparing it, let's say for the owner, for the government, they do not need to know all the details. They just want to know what is the overall, or what is the general progress of the project. How does it look like? So in that case, your time units could be bigger, right? For example, if you're talking about different phases of, for example, a power plant that has 24 different phases, and it's going to take maybe 9 years to finish all those 24 phases, then the bar chart you provide for the managers of the system would be something that just shows things in months, or even in seasons, a quarterly bar chart. So the amount of detail will depend on who you are providing or preparing the schedule for, and the purpose, right? Do you want to show how much detail are you trying to show by your bar chart? So effective communication rules is the rule of thumb in when you are preparing any schedule. It means your schedule should be user friendly. The idea of a schedule is to make understanding the schedule easier for everybody. If you create a schedule that is creating more confusion, then you're doing a poor job scheduling this project. Okay, so it should always communicate the same message for everybody. It means if two people have a different understanding of what the schedule says, it means it's not a good schedule. So when you construct a bar chart, you want to know if you're using the calendar days or if you're using the work days. Calendar days are simply every day that are shown on the calendar, including weekends and including holidays. While work days, as implied by the name, are only the days at which work is in progress. Okay, so what makes it challenging is that for different activities in a project, you could have different logics. For example, for the work that involve laborers, okay, that is almost a majority of construction activities, they require laborers. So you cannot schedule them on a weekend if the schedule tells you that we are on a 5 day a week um, schedule, then you cannot schedule anything. But there are some activities that you have to wait for it, and no matter it's a holiday or a weekend, it is in progress. The best example is curing the concrete, right? You need someone to water the concrete and to cure it, even if it's on a Sunday. So there are for different in many projects, it's quite common to have 5 or 6, if not more, different types of calendars. Okay, so based on the type of activity, then in P6 you will learn in this semester, you will learn how to assign different calendars to different activities, and you can have as many types of calendars as you want, depending on the nature of work. So continuous work is always more efficient. You should keep that in mind. Whenever possible, schedule repetitive activities continuously. That's a lesson for life. I always do that. Whenever you have a number of activities, try to categorize them into repetitive ones and do the repetitive ones together. For example, if you need to do ABC 4 times, okay, ABC, 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 ABC. Don't do it like that unless you really have to, finish the first round and then go to the second round. Always, you should try to do 4A's, then 4B's, then 4C's, and then so. This is how you should try. This is a basic logic. And while it might sound obvious, many schedulers just miss doing this, or they don't do a good job in scheduling repetitive activities together. So after one another. So an important thing is in making things repetitive or scheduling repetitive activities in a group or one after another is the learning curve. So the learning curve, you are taking advantage of learning curve when you do repetitive activities together, and trust me, it matters hugely. It could have a significant impact on how faster or slower you could get a job done. So always try to schedule repetitive activities in a row. Yes, so as you can see, there is time and productivity, and productivity is, you know, is like this in the learning phase. At the first, productivity is low, and then as the time goes, after some time, after the learning phase is passed, then you reach to the steady state phase. It means the productivity will not improve, but actually this is a good part. After the learning phase, if you see, the productivity is low throughout the learning phase. Okay, so once you reach to steady phase, you want to keep it in the steady phase as much as you can. And why I'm sorry, while this sounds obvious, there are a lot of reasons that could break a steady phase. For example, one thing one way to take advantage of a steady phase are longer shifts. Okay, when you work longer shifts, the good thing is all the materials are there. Everything is in the place. So if you just people continue working, yes, I can understand that they could get tired, or because they're human beings, their productivity might be compromised, might be lessened. But in fact, in longer shifts, since um, everything is in the steady phase, the productivity is comparatively high. Okay, so try to keep everything in the steady phase as much as you can. This is a very golden thing in scheduling. All right, back to our example. Now we have the activities, we have the durations, and we have the sequencing or the dependencies between activities. So all the three items we needed for creating a bar chart are ready. So now we can, first we create the timeline on the x-axis, starting with the first day on the left side and the next days following that. So we have three activities. We start with the first activity on top, and then we follow to the bottom. So this is how your schedule look like. This compares scheduling using work days with scheduling using calendar days. So you can see how they are different from one another. As you can see, when you're using calendar days, you're showing the weekends. Or for example, you're showing this Monday, this holiday, okay, while those days are eliminated. So on a weekday, on a calendar day basis, you will see longer bars. But when you're just seeing the work days, your bars are shorter. What is the disadvantage? What's the negative point of working with only work days? The negative thing is when, so the negative thing is for some of the activities have to continue on a weekend or on a holiday, no matter what. Okay, and when you're using work days, it's difficult to show those activities. This is one disadvantage. So you should make sure that you have another bar chart only showing if you want to use work days, you should create another bar chart specific to activities that continue on weekends or on holidays. And there could be just a few of them, but there should be a way to show them, right? So based on that, let's go ahead and create our first bar chart. So we have a list of activities. Each activity has a code here. We start from activity A. The last one is J. Durations are given. So we have the second element, and the third element is the dependencies of different activities. So let's go ahead and build it together. Activity A starts on the first day. We start from the top to bottom, and it takes 4 days. So it will look like, oh, it's behind this Zoom thing. But let me see if I can move this. Yeah. So it starts right here. It takes 4 days. So it finishes here. B starts after A finishes. It means immediately after A finishes, B can get started, and it takes 5 days. 1, 2, 3, 4, 5. C starts after A finishes also. So both of them, both B and C start after A finish. So C will fall here. Then we have activity D that starts after B finishes. So D depends on B. D as in David depends on B as in boy. D takes 3 days. Then we have E, which takes 5 days. It starts 1 day after C finishes. 1 day after C finishes. It means not immediately after C finishes, but you need to give some time. You need to wait another day, and then you can start E. Okay, so F can depend on 2 activities. It depends on both C and D. So both C and D should finish, and then only F can start. And as you can see, C and D finish in different days. So should I start when C finishes or when D finishes? I should start when both of them finish, so I have to wait for D. That's why it's actually the start date is driven by the later of the two between C and D finish days. Okay, we need to wait for both C and D to finish, and then only can start F. So what is the story of G? G can start after D finishes. Immediately after that, G starts. H after F finishes. So you have to wait for F, and then H starts, and it takes 7 days. E and G, I starts after E and G finish. E and G finish in different days. The later of the two is G, so I have to wait for G to finish. Then I starts, and it will take 8 days. And finally, J starts after H and I finish. H and I finish in different days, so the later of the two is what counts. And J will take 5 days. So this is how a bar chart is created. And if you can see, in the first 4 days, A is the only activity in progress. So if someone asks you what is the most crowded day on the job site based on this bar chart, that would probably be not probably, but yeah, the reason I say probably is that some activities could have more resources. But if all of them have equal number of resources or laborers, in day 12, 13, 14, and 15, there are 3 activities that are in progress at the same time. Okay, so these are some of the most crowded days on the job site. All right, there is a similar exercise based on that. So you have to, I mean, let's solve it together. So A starts in the beginning, it takes 2 days. B starts after A, it takes 4 days. C starts after B finishes, so right after B, and 8 days is the duration. E, 3 days after C starts, not after C finishes. So E starts 3 days after C starts. So C starts here, 1, 2, 3. So this is where I missed D. Yeah, D also starts after B finishes, and E starts 3 days after C starts. So 3 days, and then E can start, and it will take 7 days. F after C finishes, so right after C finishes, F can start. G after both C and D finish, the later of the two is D, so this is where activity G can start. And then we have H, which has to wait for 3 activities, C, D, and E. C, D, and E is the determining one because it finishes the latest. And then you have I that starts after 4 activities finish, C, D, E, and F. So the latest of all is F, and then I can start. And activity J will depend on a lot of activities, and so you should just see which one finishes the latest. So which in our case is H and I finish the latest, and then J can come, and it will take 3 days. So our schedule will look like this, our bar chart will look like this. If someone asks you what is the most crowded day on this job site, that would be day 15, because on day 15 is the only day in which actually no, that's not the only day. That could be day 15 with 3 activities, because let me show you day 15 with 3 activities in progress, and also day 16, 17, 18, and 19. You have 3 activities also, these activities. So in fact, starting day 15 all the way to day 26, we have at least 3 activities that are happening on the job site, starting at day actually 14 right? Because we have 3 here and then 3, 3, 3, 3. So you have at least 3 activities. Now, these activities could have different number of resources. For example, H could use only two resources, while G could use 6 different people. So that also depends on the number of resources each activity takes. Advantages of bar charts are they show the parallel activities most clearly, they show the flow of projects on its timeline most clearly. That's right. They're easy to understand for everybody. So, and yeah, I would say the main advantage is showing the parallel activities. In bar charts, it's the easiest to show. You can see how many activities should happen or are happening at the same time. The limitations are bar charts. This is the last slide of the day. So they cannot show how two activities are related. Let's go back to this. For example, here can you say what kind of dependency exists between C and D, between C and F, just by looking at this bar chart? Uh, yeah, you can say F is starting after C, but maybe it does not. It is not. C is not the driving reason. Maybe F just has to, just has some connection with E or has some connection with D. Okay, you can never tell. Or, for example, let's bring up a better example. Both C and D are starting after B, right? Can you say if activity C depends on B or D depends on B or both of them depend on B? You cannot say. You can just say which one happens first and which one happens later than that. But you cannot say what kind of logic or what kind of dependency uh, is, exists between these activities. And that's a big disadvantage of bar charts. So that's why we will need to learn another graphical presentation of schedule that we will discuss in the next classes. All right, that completes our class today. I see you all next time.